Welcome back, kids. We are here, Flip Geometry with Mr. Llanos and Miss Robbins. We are in the last lesson of Chapter 3, 3.5, 3-5, which is proving lines parallel. Now, in this lesson, once you are completed, you will be able to recognize angle pairs that occur with parallel lines. You will also be able to prove that two lines are parallel given some information. The first thing we're going to look at is the converse of the corresponding angles postulate. Now before, when we said if we had two parallel lines, if we have two parallel lines and they were cut by a transversal, we said before that the corresponding angles were congruent. There's a bunch of different pairs of corresponding angles, but those are two right there. But what if you don't know that the two lines are parallel? So if you know that, for instance, in this figure here, we're going to pick a pair of corresponding angles. Let's pick 7 and 5. If we know that the measure of angle 7 is equal to, let's say, 127, and the angle measure to angle 5 is also equal to 127, we can say then that these two lines, A and B, are parallel. And that's what this says up here. If two lines are cut by a transversal so that the corresponding angles are congruent, which we have right here, then the two lines, we can then say that the two lines are parallel. The next one is the alternate exterior angles converse. Again, if we have two lines that are cut by a transversal, and they have a pair of alternate exterior angles that are congruent, then the two lines, you can then say that the two lines are parallel. So, for instance, P and Q, we don't know if they're parallel or not. But if I were to tell you that angle 1 is equal to 76 degrees, and angle 3 is also equal to 76 degrees, you know these two are going to be congruent. We can therefore say that these two lines are going to be parallel. Next, we have the consecutive interior angles converse. If two lines in a plane are cut by a transversal so that the pair of consecutive or same side consecutive interior angles are supplementary. Remember, angle 4, if we know that angle 4, let's say, is equal to 73, and angle 5, and those two are consecutive interior angles. If we know one is 73 and the other one is 107 degrees, if they're supplementary, remember, and supplementary means that they add up to 180. Well, let's see, 73, that's 180. If these two add up to 180, then the two lines, you can then say that the two lines are parallel. The same thing happens with the alternate interior angles converse. If you have two lines cut by a transversal, and we know that, and you're given enough information to know that a pair of alternate interior angles are congruent, then we can say, without a doubt, that those two lines are parallel to each other. Lastly, we have something called the perpendicular transversal converse. And it said that in a plane, if two lines are perpendicular to the same line, then they are parallel. Well, let's take a look at this. Line P is perpendicular to line R because we have the right angle right there, which is 90 degrees. Line Q is perpendicular to line R, again, because of the 90-degree angle. But if you look, these two angles are corresponding angles to each other. And they're congruent because they're both 90 degrees. Then we can say that those two lines are going to be parallel. Let's take a look at a quick problem here. It says, given angle 1 is congruent to angle 3, is it possible to prove that any of the lines shown in this figure here are parallel? If so, state the postulate or theorem that justifies your answer. So angle 1 is congruent to angle 3. Let's go ahead and mark that. Angle 1 is congruent to angle 3. Okay? Now, this line here is going to act as our transversal. I'm just going to highlight it. Here's our transversal. We've got A and B. Because of the fact that these two lines cut by a transversal form these two corresponding angles, and they're congruent to each other, we can say yes, that they are parallel. If I get a pen here, they are parallel. What would we say to prove that? Earlier we talked about the converse of corresponding, I'm going to shorthand here, corresponding angles postulate, which said, again, if you've got two lines cut by a transversal and their corresponding angles are congruent, then you can say positively that those two lines are going to be parallel to each other. The last problem says, given the measure of angle 1 is equal to 103, I'm going to go ahead and write that in there. This one is 103. And the measure of angle 4 is 100. Is it possible to prove that any of the lines shown are parallel? If so, state the postulate or theorem that justifies your answer. So, we've got two lines here. Again, I'm going to mark my transversal. Always want to mark your transversal. Okay, just so you can see it clearly. We've got two lines, and now the lines that we're looking at are A and C, because those are the two lines that are cut by the transversal that form the angles that we're looking at. So we've got angle 1 is 103, and angle 4 is 100. Now, those two angles, by definition, are alternate interior angles. They're on the opposite side of the transversal, and they're on the interior of the two lines in question, A and C. Now, in order for those to be parallel, they have to be congruent. So these two angles that we're looking at, I'm just going to mark the angles, this one and this one, they are not congruent. That one measures 103 and that is 100. So no, these two lines are not parallel. And what we used was the converse of alternate interior angles or theorem. Okay, because we said those have to be congruent so that we can then say that they're parallel. But because they're not congruent, we cannot say that they are parallel. So they are not parallel. A and C are not parallel. Well, boys and girls, that's it. That's lesson 3.5, proving lines parallel. Go ahead and watch this video again if you need to. I would definitely suggest it. If you have any questions, please feel free. Do not be afraid of asking them when you come to class.